Dear students and friends, Assalamu alaikum. You are watching NPTEL Chemistry E class and I am your chemistry detective with one new chemistry class 11th NCERT problem. So our problem is in the reaction dinitrogen plus 3 times dihydrogen resulting in formation of 2 times ammonia. Calculate mass of ammonia produced if 2 into 10 raised power 3 grams of nitrogen react with 10 raised power 3 grams of hydrogen. Identify excess reactant. What is its unreacted mass? This is a numerical problem. It is based on chemical reaction, and solution of this numerical problem requires the idea of reaction stoichiometry and limiting reagent. So I will utilize ideas like reaction stoichiometry and limiting reagent in order to solve this numerical problem. Given is that before starting reaction, to start a reaction, available mass of dinitrogen that we take is 2 into 10 raised power 23 grams, and available mass of dihydrogen with which we start this reaction is 10 raised power 3 grams. Let me write reaction one more time. N2 plus 3 times H2 gives 2 times ammonia. This is balanced chemical equation because there are 2 atoms of nitrogen on reactant side and 2 on product side, and there are 6 hydrogen atoms on reactant side and 6 on product side. And I already have told you that in a balanced chemical reaction, stoichiometric coefficients of reactants and products represent their moles. So in this reaction, 1 mole of nitrogen reacts with 3 moles of hydrogen to form 2 moles of ammonia. And this information is quantitative, fixed for this particular reaction, that during formation of ammonia 1 mole of nitrogen will react with 3 moles of hydrogen, and always 2 moles of ammonia will be formed. And in terms of mass, if I will present this quantitative information, stoichiometric mass, required mass of dinitrogen is mass of its 1 mole, that is molar mass, gram molecular mass, which is 28 grams. Similarly, required mass, stoichiometric mass or required mass of dihydrogen is mass of its 3 moles. Mass of 1 mole of dihydrogen is 2 grams, therefore mass of 3 moles will be 6 grams. And mass of ammonia formed will be equal to mass of its 2 moles, and its mass of 1 mole is equal to its molar mass, which is 14 plus 3 into 1, 17 multiplied by 2, it will come equal to 34 gram. This is the quantitative information, fixed information, definite information in terms of mass of nitrogen, hydrogen and ammonia for this particular reaction. So if we will take 28 grams of nitrogen, we have to take 6 grams of hydrogen, then only we will get 34 grams of ammonia. If we start this reaction with mass of dinitrogen equal to 28 grams, then we are bound to take mass of hydrogen 6 grams and mass of ammonia formed will be 34 grams. This is quantitative information conveyed to me by this balanced chemical equation about this reaction in terms of moles and mass, and it is called reaction stoichiometry. It is called reaction stoichiometry. And second idea I said is limiting reagent. First I have to identify limiting reagent. I will go for identification of limiting reagent, whether limiting reagent is present in this reaction or not. Reaction stoichiometry says me that 6 gram hydrogen reacts with 28 gram dinitrogen. Six gram dihydrogen reacts with 28 gram dinitrogen. 1 gram will react, 1 gram dihydrogen will react with 28 divided by 6 grams of dinitrogen. Now see what is the, with what mass of dihydrogen we start this reaction. In order to start this reaction, mass of dihydrogen which we are taking is 10 raised to power 3 grams. So available mass of dihydrogen is 10 raised to power 3 grams. Now we will find out 10 raised to power 3 grams of dihydrogen require how much nitrogen. 10 raised to power 3 grams of dihydrogen will react with 28 divided by 6 multiplied by 10 raised to power 3, and it will come equal to 4 6 are 24, 4 6 4s are 24, 6 6 are 36. It will come 4.6 into 10 raised to power 3 grams of dinitrogen. If we start this reaction taking 10 raised to power 3 grams of hydrogen, we have to make sure that mass of dinitrogen we take equal to 4.6 into 10 raised to power 3 grams. For dinitrogen, available mass with which we start this reaction is 2 into 10 raised to power 22 into 10 raised to power 3 grams. But required mass of dinitrogen as demanded by reaction stoichiometry is required mass is 4.6 into 10 raised to power 3 grams. Available mass is less than required mass. For nitrogen, available mass is less than required mass. It means nitrogen is limiting reagent. We have identified one limiting reactant in this reaction. Nitrogen is limiting reactant, because it is also clear from here, because 10 raised to power we start reaction taking 10 raised to power 3 grams of hydrogen, and for 10 raised to power 3 gram of hydrogen we need 4.6 into 10 raised to power 3 grams of nitrogen. But available mass of nitrogen is only 2 into 10 raised to power 22 into 10 raised to power 3, which is less than this value. Therefore nitrogen is our limiting reactant, and hydrogen will be our excess reactant. Also justified by fact that 4.6 into 10 raised power 3 grams will react with 10 raised power 3 grams of hydrogen, but we take only 2 into 10 raised power 3 grams. Therefore 10 raised power 2 into 10 raised power 3 grams of nitrogen will react with mass of hydrogen less than 10 raised power 3. As a result, we say hydrogen is excess reactant, nitrogen is limiting reactant, and hydrogen H2 is excess reactant. Hydrogen is excess reactant, and it is this hydrogen, nitrogen is limiting reagent and hydrogen is excess reactant. Now this information is very important for me because it will allow me to find now how much mass of ammonia is formed, and it will allow me to find how much mass of hydrogen will remain unreacted, and unreacted mass of hydrogen will be equal to available mass with which we start a reaction minus reacted mass, and we have to now calculate mass of ammonia formed, how much mass of ammonia will be formed and how much mass of hydrogen will get react, so that we can calculate how much mass of hydrogen will remain unreacted. And for this very thing, this fellow limiting reactant is there. This limiting reactant will decide fate of reaction. It will help us to, it will determine how much mass of ammonia is formed and how much mass of hydrogen will be reacted and left unreacted. I will again use first reaction stoichiometry. Reaction stoichiometry says who will decide the fate? Limiting reagent. Who is limiting reagent? Nitrogen. Now I will use this basic information that 28 grams of nitrogen produce 34 grams of ammonia. From reaction stoichiometry, 28 gram nitrogen produces 34 gram ammonia. 28 gram nitrogen produces 34 gram ammonia. 1 gram will produce 1 gram nitrogen will produce 34 divided by 28 gram ammonia. Therefore how much nitrogen is limiting reagent? It will be 100% consumed. Whatever mass we take, it will be completely consumed. And how much mass we take is 2 into 10 raised power 3 grams. 2 into 10 raised power 3 gram nitrogen will produce 34 divided by 28 into 2 into 10 raised power 3, and it comes equal to it comes equal to 2.43 into 10 raised power 3 grams. I have already evaluated this value in order to save time, and it comes equal to 2.43 into 10 raised power 3 grams. Therefore, mass of ammonia formed is 2.43 into 10 raised power 3 grams. This is mass of ammonia formed. Now I have to determine how much mass of hydrogen will react and remain unreacted. Here again limiting reagent will guide me. 28 gram nitrogen reacts with 6 gram hydrogen. 1 gram nitrogen will react with 6 by 28 gram hydrogen. Now how much mass of nitrogen is consumed? Whatever we take 2 into, to start reaction we take 2 into 10 raised power 3 grams of nitrogen, and 2 into 10 raised power 3 grams of nitrogen will react with 6 divided by 28 into 2 into 10 raised power 10 raised power 3 grams of hydrogen. It will come equal to, I have already evaluated this value as well in order to save time, and it comes equal to 0.42 into 10 raised power 3. Now I will write reacted mass of hydrogen is 0.42 into 10 raised power 3 grams. This much mass of hydrogen will react with 2 into 10 raised power 3 grams of nitrogen. Then what will be unreacted? Its unreacted mass. Unreacted mass of hydrogen will be equal to reacted mass minus, available mass minus reacted mass. Available minus reacted. Available mass is mass given in the question, and available mass of hydrogen is 10 raised power 3 minus reacted mass is 0.42 into 10 raised power 3, and on evaluating it comes equal to, I have already evaluated this value as well, it comes equal to 5.8 into 10 raised to power 2 in scientific notation. This is one more answer. 3 answers I got now. First answer, mass of ammonia formed is 2.43 into 10 raised power 3. Second answer, reacted mass of hydrogen is 0.42 into 10 raised power 3. Third answer, unreacted mass of hydrogen 5.8 into 10 raised power 2 grams. Now if I may recall this numerical problem for you, our problem was based on chemical reaction dinitrogen plus dihydrogen, 3 times dihydrogen gives 2 times ammonia. For this reaction we were given that we start with mass of nitrogen equal to 2 into 10 raised power 3 grams and mass of hydrogen equal to 10 raised power 3 grams. Now we had to determine how much mass of ammonia is formed and how much, and whether there is any excess reactant or not, and if yes, how much mass of excess reactant will react and how much will remain unreacted. I said that this any problem based on chemical reaction requires 2 ideas. First idea of reaction stoichiometry and second idea of limiting reagent. I first used reaction stoichiometry, and on basis of reaction stoichiometry I got that for this reaction dinitrogen is limiting reagent and dihydrogen is excess reactant. Whatever amount of nitrogen we take to start a reaction, it will get completely consumed. So 2 into 10 raised to power 3 grams of nitrogen will completely react. However, 10 raised to power 3 grams of hydrogen will not react completely. Some of it will remain react and some will remain unreacted. And it is the limiting reagent dinitrogen which will decide how much mass of ammonia is formed and how much mass of hydrogen will react and remain unreacted. And I again use a reaction stoichiometry and found that mass of ammonia I again use a reaction stoichiometry but guided by limiting reagent, and after solving I found that mass of ammonia formed is 2.43 into 10 raised to power 3 grams and reacted mass of hydrogen is this and unreacted mass of hydrogen is this. This way I was able to solve this numerical problem. Thank you. This is what I have got for you in this short session. Take good care of yourself. See you on Monday with one new chemistry class 11th NCERT problem. And I have one announcement for you that I have reserved odd working days, I mean Monday, Wednesday and Friday for 11th class, and Tuesday, Thursday and Saturday for 12th class, because 11th ends with 1 which is odd number, 12th ends with 2 which is even number. So even working days I have reserved for 12th class and odd working days I have reserved for 11th class. 11th class students will watch my video on Monday, Wednesday and Friday. 12th class students will watch Tuesday, Thursday and Saturday. Allah Hafiz.